Okay, I think we should start.
Look at the brochure. Your warm-up man's not going to put you in the shade, is he?
My name's Tony David. I'm the Vice Dean for Psychiatry. Welcome to all of you to the Institute of Psychiatry, Psychology and Neuroscience, to the inaugural lecture of Professor Marco Catani. So, what is an inaugural lecture? I think this is possibly a peculiarly British thing, that the idea of the professor being a very, very venerated figure, the highest kind of academic position there is something that's not understood all that well in other countries. Professor just means someone who does teaching. It doesn't really carry much more than that. But for us, it really is a big thing. And yet, it doesn't necessarily come with a huge salary increase, or none in some cases. But on the other hand, it doesn't really make any demands either. The only thing you have to do is give an inaugural lecture. That's the only thing. And you'd be surprised how sometimes that's quite difficult to squeeze out of our new professors. But not Professor Catani. He was very keen to rise to this challenge, and we're all looking forward to it. There are a few more coming in the next year. Nicola Fear, who's in epidemiology and military studies, and Edmund Sonoga-Bark in developmental psychopathology. They'll both be giving their inaugural lectures in 2018. So I'm not going to say very much, just a few introductory remarks. So I asked Marco just to send me some stuff, you know, a CV and what have you, just to make an introduction. And he said, well, I'll send you two lots of information, the stuff that you should say and the stuff you definitely shouldn't say. I'm not sure I got the right one, but we'll see. But this one I have tells me that he was did his medical training in Perugia, which I gather is famous for chocolate, or a particular kind of chocolate. So I'm sure that will satisfy those with a sweet tooth. He trained there and then trained in geriatric medicine, and then came to London to do his psychiatric training in 2002. So it's been really quite a meteoric rise to fame since then. And in fact, the thing that perhaps he's most famous for is the paper that he published in 2002 with Derek Jones and Rob Howard, which launched this new method of tractography. And I'm sure we're going to see the fruits of that in the lecture. But that paper has been cited nearly 1,000 times and has absolutely revolutionized the field. What I would say about Marco is that in many ways he is a Renaissance man. He is both a scientist and an artist, and I think you'll see from the images he'll share with us why that's true. And there aren't many psychiatrists who can claim to have influenced the famous Gray's Anatomy textbook in the way that Marco has. So without further ado, it's a pleasure and a privilege to welcome Marco Catani to the podium, who's going to talk about From Rejections to Connections. Marco.
Thank you, Tony, and thank you for all of you to come this evening. And I have to say that it is true. It was my most difficult lecture in terms of preparations, and I think that's because, you know, I usually don't have such a wide audience, going from the editors of the Gray's Anatomy, Susan Standering, to my parents. So how can you kind of find a middle ground there? And they don't speak much of English neither. So I hope someone can translate for them. So when I was preparing this lecture, I had in mind my students, really. and therefore I come up with two main messages. This was a suggestion from Declan Murphy. Yeah, Declan is not here, but he said, Mark, just have in mind the main messages that you want to convey. When I asked Steve, what should I do for my lecture, he said, brief and humorous. That was his suggestion. But Declan said, think about two key messages. And the first message is to the students. They're here is actually, it's still fun to do research and do teaching. And that's why I'm still doing this, and I'm looking forward to the next 20 years. I'm going to retire in 2037, according to the paperwork. The second thing is that it's been a long path that you never know where life is taking you. So that's what I hope that will come clear from my talk, and therefore the title, which is From Rejection to Connections. Now, so I consider myself a lucky man, really, because very rarely in life it happens that you are at the right place and you come across or you meet people that are developing a new method, they're discovering, developing a new method that actually revolutionize the field that you're interested. And the method that we're talking about is called diffusion tensor imaging tractography. That was invented in 1999. And of course, there's been a long history. We had a long history of studying connections in the brain that goes back to Renaissance, even further back. But don't worry, I'm not going to focus on the past before tractography. I'm going to focus just on the last almost 20 years of tractography, and how exciting was to really be there, and you can call it destiny, I would call it just luck. I was there and I could see the potential of this method, and I married this method, and I was struck by its beauty, and I kind of never left it ever since. Just like any marriage, there was ups and downs, but I stuck to it, and I couldn't live it. I couldn't even change. But I really, at the beginning, I was not meant to do tractography at all. Actually, I was not meant to come to the Institute of Psychiatry. I was aiming for London, but I was going to towards a different direction. So I had applied. So after graduating medicine in 1997, 1998, I applied for a job at the Functional Imaging Laboratory with Mick Ruck and Richard Frakowiak. At that time was really a big centre. He's the world leading in fMRI, and being a geriatrician in training, Richard Frakowiak offered me an interview, so I went for the interview. And to my surprise, with my about 100 words of English, I managed to get an offer for a research position with them for 2 years. So I was thrilled, came back to Italy. I applied to the director of my residence program at that time, who denied me to go to London. So I had to write back to Richard Frakowiak. At that time, there was no email, but just by writing and say, sorry, I cannot come. So I must have been the only one in his life that said no to Richard Frakowiak. I was heartbroken, really. But hope came back again when I went to Vancouver, and I met Rob Howard there. Rob presented at the International Psychiatric Association. That was my first conference. I was presenting an fMRI study in healthy aging, and with a homemade software, really, only 4 slices, and at that time you would carry your material on these sort of things that that makes you laugh. I mean, if you're the young generations, but it was. So I went to this conference, and I met Rob, who gave a brilliant talk. I still remember some of his lines. He was at that time, I think still you are, Rob, interested in I can't even remember, but let me try. Very late onset schizophrenia-like psychosis. Thumbs up. Okay, so that was his baby. He was presenting that, and I remember him at some point coming up with a slide of the Queen Mother and say, schizophrenia-like psychosis is like a Queen Mother. Everybody knows is there, but nobody knows what she's there for. And it was brilliant. I never heard anyone talking like that. I wrote to him, and he said, "Why don't you come to psychiatry?" And here I am. And I arrived, and when I saw him, it was the old age psychiatrist was still in the port cabin, and that's what really we started looking at diffusion. Tensor imaging tractography. When I explain what is diffusion to my students, I usually say you have to learn these 4 words. The first is diffusion. The reasons why we call it diffusion, because we use MRI to measure the diffusivity of water molecule inside the brain. So we take a little cube, which is called voxels, inside the brain, that may contain grey matter, so the neuronal bodies, or the white matters. And when it's in the white matters, where all the fibers are all aligned, then you measure in the diffusivity of water molecules, and the diffusivity of water molecules is really constrained, hindered by the orientations of the fibers. And so if you measure it in at least 6 directions, you then can calculate a tensor. And a tensor, this is still a slide that was given to me by Alberto Bizzi. I think you did it with PowerPoint, and they're still working after 15 years, I think, Alberto. But basically, if you missed it, I'm going to show you again. So the diffusivity of water molecules is a certain directions, and what you do, you calculate these tensor, which is the 3D reconstructions of the overall displacement of water molecules. And the main eigenvectors, the red one, will be parallel to the main directions of fibers. Now, if you change voxels, you're in a voxel where the fibers are oriented in that directions, the tensor will change orientation. So here we have an indirect measures of the diffusivity of the directions of water of the fibers. Now, so we can do with diffusion tensor imaging. We can do images, we can create these eigenvector maps, and with eigenvector maps we can track these streamlines that are going from jump from one eigenvector to the other, and you can actually infer the directionality of the streamlines and have a 3-dimensional reconstructions of these pathways in the living human brain. You have different colors. Yellow is the corpus callosum, and red, in this case, is the corticospinal tract that at the moment you're not using very much, but I'm using to stand and to gesticulate while I'm talking. So there was really an amazing technique. I still remember, very emotional, looking at these images and thinking, oh, we can do that in the living human brain. Now, that was not the way I learned it. About the fusion. The person that was behind this method was Derek Jones. At that time, he was a PhD, if I remember correctly. Now he's Professor at Cardiff. Meeting Derek Jones was another very interesting experience, really a turning point in my life. Derek always pretended that he knew a bit of Italian. Simply because he could read Italian ice cream there and gelato, or he could do these sort of gesticulations about. But if you know Derek, he's always been using Italian examples taken from Italian life and to explain things. So when we met for the first time, he explained to me what was diffusion and tractography using a video. And here's the original video. Here's it, Derek explaining to me what is tractography. So this is a streamline. There's different eigenvectors and a stream. Now he's going to put them all together in line. So the tractography algorithm will put the pieces of spaghetti all together. Okay. Not only that, you can imagine me sort of a meeting with Derek and think about, is this politically correct, or is it Tony Tag coming up with this kind of a... next, he went on, and I'm going to show you what, the organization of fibers and what is anisotropic tissue. When the fibers are all together, that is anisotropic. When they're all not together, or that's isotropic. Now, the anisotropic pasta is in a plate, on the plate, and the other one is now becoming... You're allowed to laugh. I mean, they're all trying to restrain Derek. I think, and that's it. Now, the pasta is becoming isotropic. Now, when he stopped showing this video, I was furious. I never told him. I'm going to tell you this for the first time after so many years. I thought you were, you did it on purpose for me, because that was the way of explaining it to any Italians. My English was not very good. So, but no, he would do this, he'd go on and he would do this, and in case you didn't understand what it was. And okay, so now you got the concept. So the white isotropic and isotropic, and that's what we measured with diffusion. Now, it was all okay, but my hopes were still for a grant that Rob had applied to the work contrast for an fMRI study in Alzheimer's disease. And Rob said, if we get it, Marco, you're going to work on this. And I think that's great, fMRI, that's what I wanted to do. Unfortunately, Robert didn't get the grant. So the next thing I had on my desk, Robert gave it to me, was this bundle of eigenvector papers. It was Rob, my apologies, Derek. So Derek had it printed out, obviously late. It was to Rob, and Rob gave it to me and said, look, Mark, go look it through and see whether you can find some tracks on these eigenvector maps. And the next thing was from Derek, this manual called DTI for Dummies, written by, a reference for all the rest of us, written by Eigenvector there, and there are other things other things that I can't read there, but very, very funny. So, and still have it. I still have all three of those. And this is, searching for pathways. There was me looking through these, and before tractography, trying to see whether there are some pathways, understanding where the corpus callosum was, and then going through the occipital frontal fasciculus, superior longinal fasciculus, etc., etc. And so I spent a year going through those maps, and then eventually Derek came out with this beautiful way of doing tractography. And my job was to compare the classical anatomy with the tractography and come up with these images and label them. It took me a year to come up with just 10 tracks of the left hemisphere. And the reason was because the tractography was very slow, but I still believe these are the most beautiful images ever produced in tractography. That was the vivid paper that Tony was referring to. But when Derek started playing with tractography, actually the first results were not that great. Actually, this is the first paper done by Derek and Steve there, and its tractography was more about kind of the hypervoxel, if you want, or clusters of... And other two groups in the world came out that year with the same methods. It was Tom Conturo from the Reichels group and in PNS, and Suzuma Mori with this sort of in Annals of Neurology. So how did Derek manage to go from ravioli-like tractography, if you want, to vermicelli, the way he used to call it, to spaghetti, which were rather beautiful in 3D? Well, he produced a software called Spactrax. Again, people think that was my suggestion. I would have never dared to come up with such a name. That was all Derek, but I kept silent. So Spactrax. And again, it was Rob again coming in and saying, and looking back and saying, look, Derek, look at this textbook of neuroanatomy by Wendell Creek. Creek was a professor of neuroanatomy at Chicago, Northwestern University, and published in 1954 this beautiful atlas, and look what you find there. You find the stream tubes, just like tractography. So I guess Derek took up the challenge. He returned back, he went back to Leicester, came back to IIP with his ideas, written my lab to transform streamlines into stream tubes. And from stream tubes, he came up even with this 3D video of stream tubes. But of course, and this is again taken by one of Derek's presentations, if you used to attend his lectures, he would come out, we had this sort of little guy coming here. It was the wise guy who would come with would tell you with the truth. And the truth was, of course, that the stream tunes were not real, had nothing to do with the real anatomy. It was just a three-dimensional body that would take shadows and light, or give a third dimension. So, and I had plenty of time. This is from my kind of notebooks at that time, all the tracks, and I started drawings while waiting for the results of the tractography to come out. This is the archive fasciculus, and the reason why I had so much time, really, it was because it was such a slow software. I remember the streamlines were every 2 seconds, the first streamline, second streamline thing. So the archive fasciculus, you needed to define the regions of interest to display. The archive fasciculus would take about 2 hours in order to display. The corpus callosum was over a weekend, 2 days. So I had plenty of time to study drawings and understand whether it was anatomy or kind of artifacts. But that time was a luxury. I soon understood that the life becomes increasingly more and more complex, and that time really never came again, really. So I'm grateful to software, to the software that Derek's developed. That was so slow because actually the time didn't come. I didn't have the luxury of having the same time. So, and here, getting married with Rob, families are all the English guests, and life became even more complex. Here, the flat where we were living, we were living kind of ground floor. Derek was up there. The family was expanding. We're having children. This is with Alex Tulloch, and the life was also becoming more complex because I didn't have a salary to do research. So I had to apply for a clinical training in psychiatry. So I started clinical psychiatry, and I was doing research at spare time. And that it happened between 2002 and 2009. So it was a long training, but I was really grateful to retrain. And a lot of things happened, including weird things at that time, including this portrait that had Rob Howard there, other people. Derek was not here. I don't know why. And maybe we'll leave that for discussion for the drinks. But Dominic Fitch was here. And that's where I met Dominic at, and in fact there was a shift in my interest from just general anatomy. We started doing some kind of visual tracks. And Dominic, we also started sharing an office with Dominic, and we started producing for us was quite exciting papers. So for those of you who don't know Dominic, you couldn't think of two people more distant sharing an office. Dominic was all about cortex and fMRI and activation. I was all about white matters and connections. So for the first time, the cortex met the white matters, and we start thinking about networks and connections. This is a recent image, I guess, of Dominic, but he looked exactly the same 20 years ago. And I think the reasons why is because, like in the portraits of Dorian Gray, is the portrait that is aging. He looks absolutely identical. The portrait, in fact, is rather awful, but that's because he's aging. Now, we wrote a lot of things. It was exciting. Now, I learned a lot of things from Dominic. One is to be precise. When you correct your proofs, you use two pens. One is a black one for the text, and the red one for the references. And for an Italian, that was quite a challenge. So that was the first thing I learned. And then we start drawing down a lot of ideas. There was, I still have these. There was the idea for the paper, the rises and falls of disconnection syndrome. As you can see here, this is the rises, and these are the falls, going up and down. So we understood that actually we're part of a cycle where people had thought over time that the way to understand the brain was through understanding networks and connections. And there was a pendulum swinging from understanding in terms of localizationist, the activation, the cortex, and going towards networks. And we also tried to capture that excitement with some new words, like brain hodology. God has come from the Greek path, meaning pathways. But at that time, also another word was put forward, which was connecton. And this is the number of citations those two terms received. The last 12 years. So hodology, I'm afraid, Dominic, has gone flat. And there's only us perhaps citing using that term. But look at a connectome, which means exactly the same thing, trying to map the entire connections of the brain, but it really exploded. But we meant the same thing, did we, Dominic, was with brain hodology. And we started looking at the classical anatomy, and this was the anatomy of the archifasciculus as we knew it, with an area, Wernicke areas, that we used to understand language, an area, Broca's area, that we used to for speech productions, and the archifasciculus in between too. So we started looking at that with tractography, define regions of interest, display tracks, and to our surprise, there was a third area, an inferior parietal lobe, connected by the other two. And we call that area the Gaussian territory. And we came out with this parallel pathways model of the language pathways, where Wernicke's and Broca's connected by a direct pathway, the red one, and an indirect pathway through the inferior parietal lobule. And that was 2005, and I still remember the comments from the authors, from the reviewers, one saying, if this finding were true behind a shadow of a doubt, this paper would deserve to be published simultaneously in the Annals Nature and Science. It was a very, very kind of a... we never received such a nice comment thereafter, but it was true. There was doubt on the anatomy. Indeed, when we looked at individual variability, some people had a big green segment and a small yellow segment, others were the other way around. And we didn't know whether that would reflect a true anatomy variability or some methodological problem, of course, due to Derek software. Sorry, Derek. Right. So we looked at inter-individual variability in terms of lateralizations, and one of the things that we found a couple of years after we published is that if we're going to do a tractography, and let's imagine a group of us, about 60% of us would have a long segment, the red one, only on the left hemisphere, and nothing on the right hemisphere. This group is, we call it extremely left lateralized. There is another 20% of us that is bilateral, but asymmetrical, still with a left hemisphere prevalence. And there is another 20% of us that is bilateral and symmetric. You can't tell the difference between left and right. So that was quite surprising, because I thought we all had the same brain and the same anatomy. That was not the case, in fact. And to our surprise, well, to my surprise, but not to Raphael's surprise when I told about these results, there was also a sex difference in the brain anatomy. 85% of women were extremely left lateral, 85% of men belonged to group 1. So only 15% of men are bilateral. And women are 40, 30, and 30. So the distributions is more similar for the three groups for women. So there is an overlap, but there is much less chances for men to be group 2 or 3. And when it comes to correlation with performances and language performance, of course group 3 has an advantage compared to group 1, being the most prevalent in women, but it's also true for men. There is a trend. So the more bilateral are these language pathway, the better where the performances and this task. This California Verbal Learning Test is a shopping list. You read aloud 16 words, and you have to learn it through different trials. Now, we were also very thrilled by the fact that for the 150th anniversary, Susan Standring, editor-in-chief of the Gray's Anatomy, chose our image for the cover. That's very rare to happen in life. So that was another important thing for us, because we still didn't know whether what we were looking at was real or not, real anatomy. And in fact, we made it only to the cortex. There was not tractography inside yet. And that was the end of actually that first period of tractography, because Derek had been appointed professor at Cardiff University, the youngest professor in England, I guess, at that age, or Wales. And it was, it was the end really of the collaboration. So I had to find, people were coming to me, to my office. I still remember Steve coming to me and say, "Oh, Marco, don't worry, we will look after you. We will we'll support you." And I had to build a lab, and I was really lucky to have these two young men, it was a dream team. Flavio Dell'Acqua is a biomedical engineer from Milan, and it was Michel Thibault de Sostin, a psychologist from Paris. Together, the two together were a dream team. Flavio was playing at that time with something that I couldn't really understand what it was, and it was called spherical deconvolution. Basically, instead of having a tensor, you can have two tensors. Sorry, Flavio, for botching up your explanations. But basically, you can now start seeing more fiber populations. And by doing that, now you can solve problem like fiber crossing. So now the corpus callosum that you are not able to see crossing the corticospinal tract, now it's crossing the corticospinal tract. So we were able to resolve a lot of artifact with that method. And of course, other people were working on the same concept. And this was the group by Van Verdien, that at MGH, and that made it sort of made headlines in the world, because what they found really, if you look at this image down there, they found that actually the pathways of the human brain look like the streets of Manhattan. Is all 90-degree crossing. Okay, so and I remember going to France. Actually, we had to return back because we've got the passport, and being on the phone with Flower, we need to write a letter to Science to say that actually we disagree with that. And the reasons why we disagree is because Van Verdien's group was using this type of method that is able to resolve only 90-degree crossing. Anything that is below 90-degree crossing, it was invisible to them. But using Flavio Dell'Acqua's method, actually we're able to see other type of crossing, even 45-degree crossing. In fact, we measure it, and 90 degrees crossing was not more prevalent than any other smaller crossing. So there was a bit of a kind of a back and forth discussions, and Van Verdien said, oh no, I think that everything is 90-degree crossing, and he pulled out this image from, again, the Crick's textbook, 1954, and say, look, this is a tracer that's showing you a 90-degree crossing. And then Flavio took the same textbook, 4 pages after, showing that actually Crick is saying that actually it's not all a 90-degree crossing. There is also kind of smaller angles. So that's the way we replied to them. Van Verdien had reported findings suggested the human brain is organized like a three-dimensional New York City street grid. We conclude that this view is biased by the limits of their technique and does not correspond to the real anatomy. To ask the architecture of the brain seen through the lens of alternative diffusion methods, ours, bears a closer resemblance to the intricate streets of Victorian London. And that was telling you why, you had to be very careful with these methods. You can see things that are not real. But you could also see things that were actually real, in the sense that were described in the monkeys, and we could see them for the first time in the human brain, like this SLF 1, 2, and 3. These are tracts that are important for visuospatial attention. You are using this tract at the moment if you pay attention. If you're about to fall asleep, those tracts are dead. So, and the reason why we start looking at visuospatial attention is because Michel was interested in the right hemisphere. And as an app result, we started making our own software. This is Star Trek. The logo was a brain with a pork ears. I think that was a joke, Flavio, yes? We don't have it on the website, do we? With that pork ears, okay. But we did an app, a brain app. We also come up with an atlas. And it were good times. We work as a team most of the time. We organize workshops. At that time, things were a bit silly, but it was fun. But one thing that happened is that the lab expanded. A new block came in, and we're pleased to see that people like Stephanie Forkel and Sanya and Stella joined us. But I think Steph was really a major asset to the lab because she allowed to now take these findings into the clinic. That was the result of her PhD, was actually basically take that results from the PNS paper about asymmetry and say, if that is true, that there are some people that are bilateral and symmetrical, what happened when you have a stroke on the left hemisphere? Is it possible that the right hemisphere can compensate and take over? So she recruited about 18 subjects, stroke patients, with the left hemisphere and aphasia, and she assessed them 6 months after, and she tried to see whether those that recovered language were the ones that have a larger long segment on the right hemisphere. And this is the graph, and indeed, people that recovered well language after 6 months were the ones that have a larger connection on the right hemisphere after having a stroke onto the left. So those that did not recover were the ones that had a smaller long segment. That was, to me, I mean, a way of surviving, really, because tractography, I believe, if you really want to make it and survive, really has to make it, you have to turn it into a clinical tool. And that was one of the major findings, and Steffi got the cover of Brains. By that time, I also moved to the sections of brain development, and I shared brain development, and we started applying this method to other disorders that didn't have a precise anatomy. One of these disorders was psychopathy, and with it, they started with Michael Craig, with whom I started sharing an office. By the way, Michael is the one on the top, for those of you that know him. And the other one is a famous psychopath, Richard Manson. And what we found out with Michael was that the uncinate fasciculus in this psychopath, if you want, has a different anatomy compared to other tracts. So it was exciting to be able to use a method that would allow us to think in anatomical terms in these disorders. Now, and since we actually, nothing more exciting that happened in my life as a professor, as a kind of researcher, since really, because what we've been doing is applying these methods, developing more methods, and applying to different disorders. So I often ask myself, why did I stay at King's for so long? And there are different reasons why I stayed at King's. The first is that I developed a special sense of connections. First, because 1999 was not the first time I came to King's. I came in 1993 as an Erasmus student for 3 months. And I went to King's College London, it was in Kensington. Now it's sold, and very, very posh flats, very expensive. But I thought that was King's. It was High Street Kensington, not Camberwell. And I think there is a part of me that always look back and think, oh, maybe there is a King's somewhere. As a professor, once I become professor, I could return to Kensington. There was a dream that will remain a dream. There is no salary increase, as Tony said. So it will be KCL Camberwell. But this is me, and with my friends, and he got lost. He never returned back to Italy. I don't know, got married with her, and he stayed in Italy, never came back to London. So the only one that developed special connection with London was me. Also, because I developed a special connection with these two professors, Steve Williams and Declan Murphy, that I would dare to refer to as mentors, really. I know. But, and the reason why, they worked well together for me, but I'm 50-50%. I'm 50% neuroimaging, 50% neurodevelopment. I think because the reasons why they work well together, because you can think of two people more different. So I could really, so for example, I'll tell you this. When I applied for my Wellcome Trust grant, which is a big grant, very prestigious, I went to Steve. He was, oh, Mark, it's fantastic what you want to do. You want to look at connections, disconnection syndromes, fully supportive, great. And I went to Declan, gave my kind of 5 minutes explanation, was looking at me, taking notes, and I looked at me like, Michael, let me understand. You want to go to the Wellcome Trust, ask for £2 million, and for a method that will take them back to 19th century neurology, talking about this connection, what the rest of the applicants will talk about molecular imaging. And he said, forget it. You will never get it. But I did get it. So just to tell you, if you're a young, so you're applying for, you don't know which way to go for. But also, I stayed at King's because finally there was some recognitions, and I just picked the two most important recognitions. It's not only becoming professor, I finally got the Cardassians Award for Best Dressed Lecturer, which was given to me last year. But also, I got this sort of this letter for Richard Traynor. He was our previous principal. And what he said there, I don't know whether you can, but dear Dr. Catani, I've learned from our colleague, Dr. Peter Word, of your interventions in a situations, this is what reading, so I'm going to enlarge that, maybe we can. Right, can you read that? I learned in your intervention to assist a passenger taken ill on the flight to Atlanta on Saturday. It was clearly a potential distressing event which you handled with great calm and dedication, earning the respect and admiration of your fellow passengers. I wish to echo the sentiment. It is always heartwarming to hear such accounts, particularly of one's colleagues. You are a great ambassador for the college. I still remember, I didn't do much really. All I remember was boarding on this flight, and Rafaela was heavily pregnant with, help me, number 3, Cara Maria, and she was seeing all these passengers that, average mean age was about 80, 85, and she said, oh, something's going to happen. Something's going to happen. And half an hour on this flight to the United States, they call it for a doctor, and I had to do my duty. Now, the reason why I'm showing you this is, recognition comes at the end, eventually, so from King's. But you'll have to really pay attention to here, which appears, I believe, we are meeting soon at dinner. I look forward to it. Now, this is handwriting of Sir Rick, and I went to the dinner, and I couldn't really remain silent or not notice the similarity between Sir Rick handwriting and my 8-year-old boy handwriting. So this is Matteo, who is sitting here, who's taking a kind of notes during one of the lab meetings about the brain, and the similarity is striking. Now, I went to the dinner and asked Sir Rick a single question, which is, are you left-handed? Because my boy is left-handed. And he said, yes, how do you know? I didn't say anything. about the handwriting. Okay? I kind of, at that time, I was just a senior lecturer. I wanted to make it to professorship. But the reason I'm telling you this is that that was another thing that I valued about King's College. It gave me the freedom to do research on whatever aspect interested me. And handedness, of course. As soon as I discovered that my voice was left-handed, I started doing research on handedness. Now, this is Matteo, and the reason why I'm interested in handedness because I think left-handed is linked to creativity. I don't know how many of you are left-handed. You raise your hand. It's interesting. They all raise their left hand, except one. You see, there's already a variability. They are not all the same. What about the right-handed? Who's right-handed? Okay, that's more consistent. All the right-handed, they raise their right hand, except Alberto Bizzi. So, I think left-handed is linked to creativity. This is Matteo drawing the computer with the brain in it, of course, and this is a portrait of Ahmed, a member. Ahmed, just make yourself notice. So everyone, look, the similarity is striking, really. Now, so this, when I always thought there was a bit of left-handedness in me. When I saw my boy was completely left-handed, left-footed and left-eyed, I asked my mum. And she's here, and thanks God she can't understand English. And I asked her if I was right-handed or left-handed. And she told me, Marco, she's a teacher, you were right-handed from the start. Okay? And I believed her until I saw this picture of me. Age 3. And the evidence, she couldn't deny anymore. The evidence, and she said, oh, yeah, I felt so sorry for you. This is a kind of a hostile world for left-handed people, and at that time people were correcting at school. But we entered the mystery of left-handedness with this guide, and became my friend, and Pippo Zappala, who's here, is a neurologist from Sicily, and with people we did a lot of things, not all left-handedness. One thing was a very successful series of International School of Clinical Neuroanatomy in Sicily. We had a great time. A lot of the papers came out of it. And people started to tackling this mystery of left-handedness. What is the anatomy? There is no anatomy so far, of little evidence for anatomy. With Etta Howells, and she just moved to Milan now. And we were interested into the questions. Is left-handedness due to the fact that people that use the left, prefer to use the left, are better when it comes to control movement, as everyone thinks? So it's just a matter of making the right movements, the fine movements. And actually something before that is how we plan that is different, in how we plan motor commands that they plan that is different left-handed. And indeed, the connections that are important for controlling movements, for execution of movement, are not different between right-handed and left-handed in terms of asymmetry. The differences are indeed in those frontal-parietal connections that are important to put together tactile and proper set of information with visual informations, and to come up with the right plan for the execution of movement with your either left hand and right hand. In other words, if you are left-handed, you are faster at assembling whatever comes from your left side of the body faster with your right hemisphere. If you're right-handed, it's the other way around. This is all, and these correlations is very high only for those tasks that require visual spatial attention and tactile. For those tasks like tapping, there's no correlation with this asymmetry at S-left. So this is the first evidence, strong evidence of an anatomical basis of handedness and preference. And of course we went on and looked at and discovered, if you want, let me use this word, new tracks. This is a system of tracks that is in the hand knob area, and through the U-shaped fibers, the red fibers, the primary motor cortex receive all the information that's necessary for moving the hand, and with the green fibers it controls down the spinal cord and the muscles for the final movement. And of course it was a cover of the Gray's Anatomy once in life is enough, but 2 covers too much really. And we were delighted about this, but I was actually even more delighted, if you can, I mean, over the moon really, when at the party when for the launching of the Gray's Anatomy, Susan came next to me and said, "Marco, I'm thinking about that. Probably you can help us with the next editions of the Gray's Anatomy," which is, of course, I've been waiting for 2 years. And yes, Monday we had our first editors meeting, so it's really a privilege for me to be co-section editor for the brain for the next edition of the Gray's Anatomy. And there's been a long journey, because from a method that was considered full of artifacts, now to contribute to such a classic text of anatomy is really a true privilege. But it was not that surprising to me, because I always had a passion for anatomy. This is me digging up the bodies with my fellows, Burke and Hare, famous bodies snatcher. This is at Madame Tussauds, by the way. These are 2 statues. The one in the middle is me, in case you don't recognize me. A young me. This is again me and my friend, and we would like to. We thought that we were part of that sort of those people that had an interest in neuroanatomy. We didn't realize at that time that it was such a bad act, a crime that they did. Sorry, Ruth. Ruth is looking at me like, oh gosh. If I knew, I wouldn't have thought to you. But but not only anatomy, it was all about sense of connections, and this slide explains to you why the title of Professor of Neuroanatomy and Psychiatry is an unusual thing to put together neuroanatomy with psychiatry. Why did I choose that? First, because it was the only options available. All the others titles were taken. We got a professor of cognitive psychiatry, cognitive neuropsychiatry. We got all sort of terms. So there was the only one available. No, I really wanted to go for, because I think I belong to that kind of group of people that always understood the mind in relation to the brain. And these people that were famous in the past, before Freud, they were all psychiatrists and great anatomists. So I think in my title, I had a sense of belonging to that group. But I was not the only one working on pathways in the family. There was someone else. Pathways of the Pulp is a famous textbook for dentists. And Raphael, my wife, she was working not only as a dentist in the pathways of the pulp, but actually in our pathways as a family. And when you have such a larger family, allows you to do a bit of statistics. So, while I was playing with tractography, and she managed to do 4 children, become a clinical teacher at King's. She's got 3 jobs at the moment, and it's a wonderful achievement, much more than tractography. But let me go back to the statistics. I pull out my number of publications, and you can see it's not consistent. It's ups and downs. And I always wanted to test whether there is a correlation between your private life and your scientific productivity. You come across people that say, of course, either go for the family or for your scientific legacy. And other people think, well, actually, no, that's not true. Whenever I have a child, that's where I work harder and produce. And that seems to be the case for me. Whenever we had a child, I managed to produce more papers thereafter than before. And that is true for not only for children, but any other stressful events in life. Like wedding, for example. Hey, this is my a peak. And even in a midlife crisis, that's another peak. So the journey continues. Has been a lot of fun. And it was exactly 20 years ago where I graduated from medicine, and it'll be exactly in 20 years that I will be retiring. And I hope that I will continue to work with the same people, the same kind of people that shared the enthusiasm, the passions for the last 20 years. A lot of them are still in the lab. Most have gone back in their own path, and a lot of them were my MSc students that became PhD and postdoc. So I really would like to thank them and thank you for listening.
Children. But just remains for me to ask Mr. Steve Williams to come and give a vote of thanks.
Thank you, Tony. And thank you, Marco, for a very enlightening, entertaining lecture. Ladies and gentlemen, boys and girls, all your guests who have travelled from far to be with us today, I've been asked to give the vote of thanks, which in Italian I believe is voto di ringraziamento. That's about as much Italian as I'll be able to say. But when I think of victory in Italians, you think of the 4 F's. Family, food, fashion, and football. Now, of those 4, maybe the football one we will probably be working about at the moment, so you can know about the World Cups. And perhaps that 4th F can be replaced with the word Versicolare, like we saw from all those slides. We saw those beautiful streamlined spaghetti pulling together those different parts of the brain, and then just improving our understanding all the time. So working backwards, fashion. As you can see from Marco, he was 3 years old. In his fashion, he was a trendsetter even then. He wasn't a follower of fashion. And that's reflected in his science. As you can see from his publication record, over 100 papers, 10,000 citations, a Page Index of 50, if that means anything to you. That means that he's had more than 50 publications cited by more than 50 different groups around the world during his short and very productive career. And the benchmark is that if you have a Page Index which is higher than your age, then you are truly an international star. And that's without doubt much younger than 50, I'll be pleased to say. So plenty more time for that increase in family. So anyway, so we mentioned the fashion. We mentioned also, it's mentioned a couple of times tonight, I wanted to also come back to the Grey's Anatomy. I remember when Marco first came into my office and he brought some of those first images of tracks. And I said, bloody hell, Marco, you're going to be able to rewrite the anatomy textbooks with this. And he went, yes, I am. And lo and behold, a year later, using this thing called Vivid, virtual in vivo image dissection, he was then bringing forward those things that appeared on the front page of Grey's Anatomy. I'm delighted to hear, and it was news to me about your increasing involvement with Grey's Anatomy, so that's absolutely fantastic news. Food. Italian food. Italian food is colourful, liked by one and all, but a little excessive after a few hours at the table. So maybe that's maybe another way we could sum up Marco. To say he's liked by everyone that I've ever met. He's very colourful in his persona, as I say, but sometimes it's too much to take in. He's full of good ideas, new directions to take work in. But finally, family. Family, as you can see, is very important to Marco. Not only his intimate, personal family that he has, but also his family at work. You see on the slide there all those people that have touched and worked with him, and he was very magnanimous in the way that he covered all of their contributions tonight, from the people like Derek that moved to Cardiff, and people like Flavio, who is the most highly co-authored person in all those papers. There are 23 papers that Marco and Flavio have done together over the years, and that's something to be proud of. And so he really treats that family aspect very importantly. And the way that he continues to commit to the Institute, to our work and our endeavour, I am so flattered. I'm so pleased he got that grant. And I'm delighted and hope that he'll spend the next 20 years of this year pushing forward the boundaries of psychiatry and understand a lot more about everything from autism to schizophrenia. So I'd like to ask you all once again to join me in thanking Marco for a beautiful lecture. Maybe we can have Chianti and Prosecco, whatever it might be upstairs to celebrate further. But thank you so much.